Nice drums here, huh? Beating drum. Welcome, folks, to the presentation Spatial Computing, Azure Mixed Reality, Digital Twins, and HoloLens 2. Sounds like a mouthful, and it's quite a bit. And so it's just me, a few slides, and code that is standing between you and beer, or pivo. So I will try to do my best here that we have some interesting things in the next hour or so. What we're going to talk about is, first of all, spatial computing. I explain what that actually is and what I mean with that. I will show you lots of use cases as well, including, of course, digital twins, but also a few more. And then we dive into some of the Azure Mixed Reality services that are available, like Azure Spatial Anchors, and we will actually do a little demo. I will show you some code, how you can build a minimal Azure Spatial Anchors application with Unity. And you will also get the source code, of course, on GitHub. I will also show you Azure Object Anchors, which is also pretty interesting, and then Azure Remote Rendering, which is an amazing service that allows you to render very complex 3D models in the cloud and stream it real time into the HoloLens 2. What else? Well, we will have a little bit of code, like I mentioned, so we'll do some live coding around Azure Spatial Anchors. My name is Rene. I'm Director of Global Innovation at Valorem Reply, work on topics like AI, computer vision, spatial computing, but also quantum computing. I'm also Microsoft Regional Director and MVP and advisor for the VR and AR Association, as well as XR Bootcamp. But first of all, let me explain to you what is spatial computing. And in order to do that, we need to go a little bit back in time. Personal computing was really a thing in the, let's say, the 90s or so, when a lot of people had their first PC at home. And it really changed the game once they became connected through the internet, right? You had all this knowledge sharing, all the democratization of knowledge sharing that really changed a lot how we also, interact as humans. After personal computing, mobile computing came along, and mobile computing is really the dominant computing platform these days, right? With mobile computing, you, of course, have some context awareness. You have GPS and so on, so you know where you are in your environment, but that is very coarsely, right? Not very precise. Mobile computing is, of course, the dominant computing platform in certain countries. Started with mobile computing. There was no PC, right? I recently gave a talk virtually in South Africa. And for example, in Africa, they start with mobile computing. There was no PC, right? And so after mobile computing, after personal and mobile computing, we're now entering a so-called spatial computing age. And that is based on these intelligent edge devices, which could even be your smartphone you might have in your pocket, right? Like the one I have here, it's just a 2-year-old Samsung, which has a depth camera, so it can sense the distance to objects, can measure that, and generate a map of your environment, right? But even without these depth cameras, modern mobile phones, Android has AR Core as an API set, and iOS you have ARKit. All of these can sense the world around you to some degree. They can reconstruct surfaces. So this device could, for example, understand there's a floor, right? There's a ceiling. Well, maybe it's a little bit too far here. But, it can understand the environment. It can spatially sense the environment. That's possible with a mobile phone. But of course, even better with a device like a HoloLens you put on your head. And you probably have seen it before, right? Mine has little shades here. You might not have seen that. That's pretty cool. So I have a little foil here, right? So I can use it better outdoors. It's like my hacky sunshades kind of a thing. But as you know, the HoloLens has these semi-transparent displays where you can see virtual objects blended in your environment. And in order to do that, it needs to understand the environment. It needs to spatially sense the environment. And it does it with a depth camera here and a bunch of normal RGB cameras here that are actually monoscopic RGB cameras that are used for tracking. So the device knows where it is in the room. But regardless what device you have, right? If it's such one or this one, all of them can sense the world around us. All of them are spatially aware. They generate a so-called spatial map of the environment. And that's why it's called spatial computing. Because in our computing, we can bring in more context. We can bring in more things where the user is from the environment. We can provide better and contextual information. And this with a precision up to, well, it depends on the computer vision, but much more precise than GPS, right? So in order to explain it a little bit better, like I mentioned, it doesn't matter really what kind of device you have. And if you take a look here at this nice video from Microsoft, You can see like the lady, for example, she's using a HoloLens here, and a gentleman is using a tablet, right? But they can all collaborate together because each of these devices can sense the environment and basically can reconstruct in 3D where they are and then bring in contextual information, right? And it doesn't matter if it's a mixed reality or augmented reality device or even a virtual reality device, right? All of these devices track themselves and the environment. They track where they are and provide that information, right? So this lady in VR being remotely present there thanks to the mesh platform here. But anyhow, really the key here is spatial computing. Doesn't matter what kind of form factor, but each of these devices can sense the world around us, and we can do some pretty cool stuff with that. The challenge, though, is each of these devices senses the world a little bit differently. Of course, a HoloLens has a much better spatial map with all the dedicated sensors, right? This one is not so detailed. And the key here is we all need to communicate with each of these devices together, right? And this is enabled by a technology called the AR cloud, the augmented reality cloud, which is basically a common map. So these devices generate a map about the environment, and if we bring them all together, we get a spatial map of the whole world in the end. We get this kind of digital content layer on top of the real world. We get a machine-readable spatial map. And with this, we can do things like that, right? We can bring in virtual panels in the real world. For example, I could go to a place, scan it, drop a virtual character there, and then the family comes with their device, and they will see it at the exact same location. Because all of these devices share this AR cloud map, this spatial map, if you will. Some might call it the real-world metaverse, right? This layer, this digital layer on top of our real environment, if you will. What are some of the use cases? Well, first of all, let me explain quickly what a digital twin is. I'm sure most of you are aware of it, but I want to make sure we're all on the same page here. Well, a digital twin is, in its essence, a digital replica of a physical entity, right? And so in this case here, it's a jet engine, as you can see. And this jet engine is being represented as a 3D model. But the 3D model is basically dynamic. And it can have IoT sensors in the real jet engine that you will see on the virtual jet engine, basically represented. So instead of having to look through a large table where I need to find all these sensor values and where is the sensor and what is the value, you can actually see it in 3D, right? And that is providing you quite some benefits here for better insights. And so here's a quick application which we built with the HoloLens. In this demo, you can still see the HoloLens 1 here. And it's basically a digital twin of a chemical plant. So we have this chemical plant, it's a real chemical plant, right? And this real chemical plant has a bunch of IoT sensors deployed. And if you look closely, you can see these IoT sensors and you can read out the sensor values, right? So there are real IoT sensors in real chemical plant. We can see them on this 3D digital twin with the HoloLens, and we can bring it into the scene, and we can even scale it up to 1-to-1 size. So you could even walk inside of it in this virtual replica. We also have a second part here in this experience, this kind of, well, you might call it a digital twin of this sensor box, and there's kind of repair instructions how the user can repair those. Another quick example is, of course, remote assistance. That's a really, I would say, a topic that is gaining a lot of attention, especially during our pandemic times, where travel is restricted, and so you can bring in remote experts from anywhere in the world and help you with your on-site assistance. And so what it does is basically, you can see the lady wearing a HoloLens. Her camera feed is streaming real time into Teams, where this gentleman is sitting just in front of his PC with Microsoft Teams. He can see what the lady is seeing first-person view. And the cool part is he cannot just provide audio instructions, like tell her, hey, open this like that, and whatever the instruction is, but he can also draw into the space. So he could draw like a virtual kind of arrow or something in the space, right? And the lady would see it in front of her. And so that is, of course, providing a lot of return of investment here. Immersive Metaverse workspaces. It's a lot of what is that? Metaverse workspaces? What is he talking about? Well, there is this new platform that Microsoft is developing. It's called Microsoft Mesh. And Microsoft Mesh is basically a development platform where we as developers can build custom applications on top, if you will, Metaverse applications that are cross-platform and also connected with each other. So Mesh is not an application that you can just use, but it's a platform you can build on top of and leverage certain capabilities. And I'm going to show you a demo application that is available on the HoloLens store. It's called the Mesh App Preview from Microsoft. So basically, it's a demo of the Mesh platform working on the HoloLens. And what you see here is, well, an avatar of myself, and the other avatar is from my colleague Jesse, who is living in Seattle. So I'm living in Dresden in Germany. And so this is 9 hours time zone difference, right? And if you look closely when we do the high five, right, there's no delay. Like, that's what they really nicely figured out with Mesh, which is a very hard challenge to solve, is this kind of multi-user sync, right? That you don't have a lot of latency, that you don't have a high delay. And that has been solved here pretty well. Another benefit you get from Mesh is, of course, you have the capability to load in 3D models. They can be locally rendered, but they can also be remotely rendered with Azure Remote Rendering, which I'm going to show you in a few slides. Also, of course, spatial anchoring is possible. And again, it's cross-platform. So this is for the HoloLens. The goal is with Mesh that it will be available for PC, Mac, iOS, Android, and Quest, Oculus Quest, like VR headsets, right? So this is a really nice thing what Microsoft is building here with Mesh. And you might have seen they're also using this Mesh platform in new formats. Like you might have seen at the Ignite conference, they announced this Mesh for Teams, right? Where you can have, in Microsoft Teams, you can have these little metaverse spaces, if you will. And this is also building on top of the Mesh platform, right? So Mesh is basically the platform for Microsoft's metaverse, basically. And if you want to, build Mesh applications, the goal is, of course, that they can all work together in the end, right? Because they're built on the same platform. We'll see how that turns out, but pretty exciting, of course. So, but let's come to those. By the way, Mesh is not available yet. It's in a private preview. I don't know when it's coming out, but I hope we will rather sooner than later get access to it, developing custom applications. But Mesh is basically using all of these Azure Mixed Reality services. So you can also use them as part of Mesh. And 2 of them are already a general available. And the third one, the Object Anchors, is in preview at the moment. So let's walk through in detail for each of those. And for Spatial Anchors, we're actually going to do some coding. But first, let's look into Azure Remote Rendering. What is that? Well, Azure Remote Rendering allows us to render very complex 3D models that are impossible to visualize or render directly on the device itself. So a device like a HoloLens is mobile, right? Which means it does all the computing in here. So there's no cable needed for my PC or something, which means it's great. You're untethered. You can freely walk around. On the other hand, you have limited computing power, right? So you cannot bring in like your 50 million polygon model with real-time ray tracing or whatever. It's just not possible. But you can do that if you remotely render that in the cloud. And that's what Azure Remote Rendering actually enables us to do. So here's an example of this 18 million polygon model. So this is, for example, a model that from an engine, really nice, well done, probably by a designer, right? So typically in engineering, these kind of products are being designed with CAD, computer-aided design, or CAD. And they produce very, very complex, detailed models. And you could never even render 18 million polygons. You would have to decimate it, which means you would have to do a model reduction, as you can see over there, to 250,000 polygons. That is something the HoloLens can render. But as you can see, it looks terrible because you have a lot of information loss, right? You remove all that information, the geometry is being reduced, and you have a lot of information loss there. So HoloLens can render 250,000 polygons natively on the device. Actually, it depends, right? It can be 200,000 sometimes, can be 300,000 or 400,000. It really depends on kind of a model you have, like what is the size of the triangles, what kind of shader are you using, a bunch of these kind of things. But definitely would not be able to render like a 60 million polygon model. With Azure Remote Rendering, you can render with the standard tier 20 million polygons, and then there's the premium tier, which is around, well, they claimed up to 1 billion polygons, right? So let's say hundreds of millions of polygons. So how does it work? Well, basically, like I said, you have this complex model, let's say a CAD model. In this case, it's kind of a robot arm, as you can see there, right? So someone designs it. Now you want to review that in 3D, because like just looking at your 2D screen, right, is not giving you the full understanding of that model. So you want to bring it to the HoloLens. So what you need to do is, basically, you have to upload that model to Azure Remote Rendering, because they're using a proprietary format for the rendering. And so you can use an FBX or GLTF 3D model as an input format, upload that to the Azure Remote Rendering Conversion Service, and then it will convert it into this runtime format that ARR is using. So that's a pre-setup step, if you will. And then once that is ready, you can start a session, basically, which means you're requesting that in Azure, basically a VM is spinning up, or actually with the recent ARR update, they're actually using a pool of VMs. So it doesn't even take a minute or so until it starts. Now it just takes a few seconds. So it will spin up basically this complex, or this powerful machine that has a very beefy graphics card in Azure, will start the session, and then it will stream real-time the visualization to you in the HoloLens. So you can visualize that in real time. And of course, what it sends is not just a flat 2D video, but it's actually sending you one for the left and the right eye, because you want to have stereo 3D, plus the back buffer. And the back buffer allows us to combine it with local content. So I don't have to render my whole scene remotely, but I can render, for example, the UI elements locally, or very small model I can render locally, and just do the very complex one in Azure Remote Rendering. And that works real time really well. I'm going to show you some videos in a moment. But basically, in a GIST, what it does is it takes the input from the HoloLens, like when the user rotates their head or moves, you need to update the visualization, sends that to the Azure data center. Of course, you want to pick one that is closest to you, like West Europe or something. And then it streams it real time back to the HoloLens. And initially, when I tried it out, I was quite skeptical if that really works. But, well, guess what? It actually works fantastic. And here you have a quick demo that I recorded a while ago. And you see an 18 million polygon model. Well, it's the same engine you have seen before. And this one will basically render real time in the HoloLens, right? So I can visualize that model. I can interact with it. I can slice through it. I can move parts. I can do, I'm just walking around this interaction, right? And so it constantly updates, and there's no delay. You have to keep one thing in mind when you do these kind of video recordings with the HoloLens. There is a downside to it. First of all, you cannot see it in stereo 3D right now. You have to see it with your own eyes. And a second, of course, there's a little bit of jittery and a little bit of lag you might see. That is not the case if you try it out with the experience yourself. That's only because of the video recording with the HoloLens. But yeah, that's Azure Remote Rendering, basically. Here's another interesting demo recently recorded. It's basically a point cloud visualization. So what we did is, at Reply, we're one of the few partners in Europe that has a Boston Dynamics spot robot. Actually, we have two of those, like this little robot walker, the kind of robot dog, probably have seen it, right? And you can buy a LiDAR sensor for it. So basically, on this robot dog, you mount a laser scanner on the back. It does a 3D scan. And that's what we did with one of our offices in Milan. So we had the robot dog walk around it and stopped every few meters, took a 3D scan, walked around, another 3D scan. In the end, you get a super large point cloud. This is a point cloud that has around 1 billion points. And then I turned it into geometry, right? Because your point cloud visualization, you cannot render with Azure Remote Rendering. You need to convert it to geometry. That's why you have a lot of artifacts in here, right? So you would need probably to do some cleanup in the end. But the geometry here is 65 million polygons, rendered real time on the HoloLens thanks to Azure Remote Rendering. And that is a really nice workflow, right? You can create your digital twin of real objects rather quickly with these laser scanners. You can visualize the real-time raw data as it comes out without any reduction and get full insights here. Okay, let's talk about Azure Spatial Anchors, or short ASA. By the way, I have some demos for Azure Remote Rendering as well. I will have, at the end of the session, I will have a slide with all the links to all the source code and things like that, right? So you don't need to write anything down. But let's talk about Azure Spatial Anchors, the second really amazing Azure Mixed Reality service. What it does is it allows you to leverage what I explained initially, this kind of AR cloud, right? You have this kind of digital content layer on top of the real world. And with Azure Spatial Anchors, you can put an anchor in the real world and attach virtual content to it. And it will stay where it is in relation to the real world. I will show you lots of examples to make that less abstract. So what it allows you with Azure Spatial Anchors, you can have these real-time collaboration applications, right? Cross-platform in the end. So you see this little sample with a tablet, right? Uploading an anchor into the cloud, then the HoloLens can load that anchor data, and basically both of them share the same anchor, which means they share the same reference location in the real world, and therefore they can collaborate with each other, because both see the virtual model at the exact same location, right, in relation to the real world. So you can share across devices, and you can also share over time, because you can persist these anchors. You can save an anchor and then load it at a later time and come back and basically have the same visual experience that you saved there before. And the third nice feature is wayfinding, like indoor navigation, if you will, because you can set an anchor here and there. You can connect these with each other. Under the hood, it actually builds a graph. And so you can enable these kind of scenarios, right, for wayfinding or indoor navigation. And again, this is all based on computer vision, right? I will show you a little bit more in a few minutes. So what is an anchor again? Well, if you think about a spatial anchor, you can also think about a ship anchor, right? So ship has an anchor, it won't move. In our case, it's of course not a real ship anchor, but it's actually a coordinate system, an anchor. And this coordinate system will stay where it is in relation to the real world. So even if the user moves back and forward with their device, it won't move, right? This coordinate system will stay there, the anchor will stay there. And then you can attach a virtual item to it. And that means this virtual item will stay where you put it. And you can then also bring in a cloud spatial anchor, where your friend, you can share that anchor with your friend, basically, and thanks to ASA, you can upload that anchor from your device into the Azure Spatial Anchor service, and then you can load it on the other device, and it will basically match it into the tracking system of the device, which means both users basically have the same reference location, the thing I explained before. And you can also persist it, so you can, again, come back a week later, load the same anchor. You might have even changed the device. You might have rebooted it or whatever. It doesn't matter, because your anchor is persisted in the cloud. You can load it and then visualize it at the exact same location. And so how does it work under the hood? Well, basically, it's working like this, that it's using so-called features. So it's in the end, it's using computer vision. And in computer vision, you would say, okay, these are feature descriptors or features. So basically the relevant information from that image. So you don't need the whole image. You just need the essential piece that you can recognize it again. So you need to extract the features. And that's also very important in terms of privacy and security, right? I mean, just think about it. Like, all folks, like, they walk around with their device, like, hey, I'm going to scan this, right? So I don't want that my camera frames go into the cloud. And it's like, what about my privacy, right? Especially also when we're dealing with enterprise customers also, right? They will never, like, if you think about like the whole spying and things like that, they would never accept that the camera data goes into cloud. Good thing is, with Azure Spatial Anchors, that's actually not happening. What they do is they're extracting these features locally on the device. So the camera frames are being analyzed, features are being extracted, and only that is being uploaded into the cloud. And basically what you see on the visualizations, the features are the green dots. So on the left hand, you see the real building or the real scene, and the extracted relevant informations are these green dots, the feature points. And a set of these feature points makes up an anchor. So this is your unique way of localizing it later on. In fact, they're actually not storing it in this way. I know the team quite well. It's from Professor Mark Polyface at ETH Zurich. It's a mixed reality lab there. And they pay a lot of attention to privacy. At a computer vision conference recently, they released a paper like privacy-preserving structure for motion. So this is really like one of their things. In fact, they're not storing the points, they're storing like vectors. So it's impossible to reverse engineer to real-world scenery, at least with a reasonable amount of effort. So with Azure Spatial Anchors and their AR Cloud implementation, they pay a ton of attention to security and privacy. I don't know about the other vendors, right? So you always got to think about, like, if you're using a service from a certain company, what is their business model, right? Microsoft business model is, well, selling services and products, right? Other companies, they're maybe selling user data, right? So you got to think about, like, who you trust with that kind of data. So what are some of the use cases? Well, collaborative design review is always a common one. And here's an app we built using Azure Spatial Anchors. And what you see here is recorded on an Android phone. And so the gentleman is scanning the place a little bit. You see the overlay there until there's enough feature information, right? Until we have enough feature points so that we can uniquely identify this anchor. Then you see this little anchor visual. But now pay attention to the lady. So she's also a little bit of scanning, but she's using an iPhone. So with an Android and an iPhone, both now share the same anchor. What we also integrated is OneDrive, so you can load a 3D model from OneDrive and then visualize that. So this allows us to have these kind of collaborative design reviews, right, where you can bring in a 3D model. You can, for example, like in this case, well, you can see if that new kitchen sink would fit into the space. But if you think about a professional application of it, of course, it could be also in a factory, right? Does that new machine fit into the space? And of course, you can already do that in AR. But with the spatial anchor technology, you can share it with multiple people at the same time, and you can save it and whatnot. So this is just one example for sharing. Here's another one for saving. So here I'm loading a session that I saved in front of our house. Look at this, little Santa's here. Christmas is soon. Do you actually realize that Christmas is in a month or so? It's crazy, huh? But anyhow, what is that? Well, it's a 3D scan. The right one is the real, the left one is the 3D scan of it. And yeah, so it's pretty neat because you can do these 3D scans with mobile devices. In fact, this 3D scan there was done with this phone. Like 5 years ago, you had to get to a large studio and do like a full scan. Now we get this kind with these depth cameras, or Apple calls it LiDAR, right? It's all this pretty similar technology. It's time-of-flight cameras, and they can do some really amazing 3D capturing. But that's a topic for another talk. But you can load an anchor, right? And I had this visual attached to it. So that is the key here. Or you can build AR historic portals, like I call it time machine portals, but it's basically a video that I put in front of the real world scenery. And what you see here is a video I got from the public library in Dresden, right? This is where I live. And this is an old video material before the war, right? And so basically what I did is I provide this time machine portal back into the old times, and pay attention to the church towers, right? This is the Sophia Church, and that was not rebuilt after the bombing. So it looks a little bit differently today, right? But you can have an overlay, and I don't need a QR code on the floor. I don't need any marker, nothing. The real world is my marker. Basically, the user experience is like this. They come to the place, scan a little bit. Okay, yeah, I'm here. Then they hold up the phone. Oh, and they can see the portal, right? Right in front of them, and have this kind of look back into the old days. Well, and you can do some pretty fancy things these days with AI. So this is the same old video clip, enhanced by my friend Eddie Hu. He used a bunch of, basically built an AI pipeline, 3 AI models being used here. One that is providing the colorization, automatic colorization, right? The second is 60 frames per second. So we have frame interpolation for very smooth kind of animations. And the third one is it's upscaled to 4K. So from this very old material, it's upscaled to 4K, which is really nice. And as you can see, when I walk close, it will stay there, right? Of course, it doesn't match perfectly to the background, but you can look closer into the portal kind of a thing and look at the faces and all of that. It's incredible. It really feels like you're there. But you can build such things with Azure Spatial Anchors, right? You can put an anchor there and boop, see that information. And wayfinding. Wayfinding, already explained it, right? So you could take an anchor here, another anchor there, another anchor there, and then you can connect these with each other. And you can bring in robots now as well. So we can basically have our little spot robot here. There are others as well, right? These are called AMR, autonomous mobile robots. And they also sense the world around them. They have advanced sensors, right? As you can see, it builds a map of its environment. It builds its own SLAM map. But it just lives on this device. But there's an SDK now for Azure Spatial Anchors for ROS, for the robot operating system, which means you can share the same spatial map with the robot that you can share with your mobile, that you can share with your HoloLens. And if you take close attention, there's a gentleman. Look at him. He's using a HoloLens. And so you can basically control the robot with a HoloLens. Because what you need to do actually now with the Bus Dynamics, you have a remote controller, right? You need to walk the robot around. Or you need to plaster QR codes all over the place so it can recognize the spaces. With this technology, you don't need anything like that. You can share the same map, and then you can say, okay, here's an anchor. Robot, do whatever action there, right? For example, like take a photo of, its security is still in place and so on. But anyway, with this kind of technology, we can also build these wayfinding experiences. Before we dive into the code, I want to quickly also show you the third service, which is in preview right now, Azure Object Anchors. Azure Object Anchors allows you to anchor content not in the world, but to an object. So Azure Spatial Anchors, ASA, what I've showed you before, is so-called world logging. So I can log an anchor in the real world. With object anchors, I can log it to an object. So for example, I could say, okay, this U, I have a pattern of it, and I can log an overlay to it, right? So I would put on the HoloLens, I look at it, it would automatically recognize it. And then, use that as my 3D anchor, if you will, or my 3D marker. Here's a quick example, which I got from a friend, which they built with a Tesla. And it's using Azure Object Anchors. And as you can see, it goes so quick. Let me do it again. Basically, the experience like this, you put on the HoloLens, and then you look a little bit at the car, and it will quickly recognize, okay, I have a pattern of that car. So I need a 3D model, of course, of that car. And then it will recognize this and provide the overlay. Look how fast it goes, right? And then you have the overlay and can see the visuals on top of it. And in comparison to Azure Spatial Anchors, if I would put in Azure Spatial Anchors there, it would log it to the parking spot, right? If I use an Azure Object Anchor, it logs it to car. So if I move the car to the next parking spot, and then I look at it again, it will recognize it. So that's the main difference. So you can log content to objects. Currently in a preview mode with AOA or Azure Object Anchors, but definitely worth checking out if you want to build something like that. All right, so we talked quite a bit about some of the motivation why you should care about it, and I showed you a bunch of use cases. And now let's talk about how you can develop for Azure Spatial Anchors, because we're here at the developer conference. First of all, it's fully cross-platform, the SDK for ASA. And you can use it for HoloLens, for iOS, for Android, and like I said, also for ROS now, for the robot operating system. And you can use it natively with the respective languages, right? On Android it would be Java or C++, or on iOS, Objective-C, Swift, whatever. Also, you can use Xamarin, at least for the iOS and Android part. And you can use the Unreal 3D engine you might be familiar with, at least for HoloLens, iOS, and Android. Or you could use the famous also 3D engine or game engine, if you will, Unity. Although Unity is still branded as game engine, it's actually not just used for games, right? There's so many professional applications that are being built with Unity. Everything you want to build with 3D is well suited to build with Unity or Unreal. And so you can build cross-platform with Unity and Unreal for HoloLens, iOS, and Android. And I'm going to use later Unity, in fact, because it provides already this kind of cross-platform capabilities. And now I have the ASA SDK, which provides me the spatial anchoring. So what would a typical solution look like if you build one? So if you, for example, save an anchor, or it's rather the flow, I would say. It's not the architecture, it's rather the flow, basically, for the anchor creation. So first of all, if you want to save an anchor, you need to upload that anchor from your local client into the ASA service. And what it returns you is an ID. So there's a unique GUID that you get returned for this anchor, and you need to keep track of that. Because if you want to locate an anchor, like, you already saved the anchor, then you come back to the same place, scan a little bit, want to locate the anchor, you need that ID, basically, because you need to provide that ID to the Azure Spatial Anchor service, and then it returns you the anchor it had. So you got to take care of a database or some kind of storage mechanism where you store these IDs. And so the third step would actually be, after you get the ID back, you would save it, and then, for localization, you would first of all get the ID from your database. This is the typical way. There's also two other ways, which I'm going to show you in a few slides, so that where I don't need to save that ID, where you can say, okay, I'm at this location, give me all the anchors that are around me, which is a rather more of a production use case. So what are the key API concepts? First of all, you have this Cloud Spatial Anchor session, right? So you need to start such a session, and that allows you to create, locate, update, and handle everything with anchors, basically. And if you want to create an anchor, you would have to call a method on the Cloud Spatial Anchor session called createAnchorAsync, and then you pass in a Cloud Spatial Anchor, and then it will save the anchor and return the ID back. What is a Cloud Spatial Anchor? A Cloud Spatial Anchor is actually pretty interesting, because what they use is pretty clever. They leverage the anchoring system of the platform already. So Android, iOS, HoloLens, Magic.ly, whatever, they all have this kind of anchoring system, a local anchor that is just living on the device. And so basically this cloud spatial anchor builds on top of it, but makes it shareable between all of those, right, via the cloud. And so it stores the ID. You can also define a dictionary, like a key value property back kind of a thing, and an expiration date. So you can say, okay, this anchor should be valid for 2 days or just an hour or forever. So you create an anchor async, you upload the cloud spatial anchor. If you want to find an anchor that you created before, you would need to create a so-called watcher. And the watcher is something that when you do the localization, you scan like this, it will run in the background and basically watch for the information in the environment and then try to match it to your anchor locate criteria that you specified. And so you can say, okay, I have a bunch of IDs, an array you can define. Okay, I have anchor ID ABC. You can give that as identifiers and then return all of the anchors with the ID. Or you can use this near device criteria, which is using a so-called coarse relocalization. And this near device uses GPS or can use Bluetooth or Wi-Fi fingerprinting to give you a coarse location, basically. And then it can tell you, okay, I want all anchors 50 meters around me. Another one is near anchor that is used for wayfinding. So you can put in a source anchor and you can tell, okay, give me the next one in your anchor graph under the hood. And so you would use that for wayfinding scenarios. All right, so I will have another slide with all the links I mentioned. But basically what I'm going to show you is a minimal sample with Azure Spatial Anchors that I created. Because if you look at the official samples, they're a little bit too complex, I think. Because what they're trying to achieve is they're trying to do, like with the official samples, they're trying to do full cross-platform, iOS, Android, HoloLens, and then also all different scenarios like wayfinding, sharing, and so on. So it's a little bit too complex. You might say it's a little bit over-engineered, but that's the case, basically, if you want to build a sample that does everything, right? And so that's why I built one minimal sample, and we can nicely walk through the code, and you might be able to understand that. Before we do it, I'm quickly going to show you what we build, basically what we're going to build, what it will look like if you run it with the HoloLens. And so this here is in our garden. And first of all, what you see here is this little overlay, right? This mesh overlay, like these lines, this wireframe. This is the spatial reconstruction of the HoloLens. So this is how it reconstructs an environment, right? And when I tap here, like provide this input, you can see it creates an anchor, like a little text there. And so I create an anchor. Now it created the anchor. I got an ID back from the service, right? And so that's basically the first step. We want to create an anchor. And the second part is what we want to be able is we want to localize an anchor. So if I tap again, it just takes a second here. All right. So tap again. Whoop, everything cleared, right? Everything gone. Basically, all local information deleted. And whoop, it quickly found the anchor I saved before. So let me show you that in code. How does it look like? First of all, like I said, we're going to use Unity, and I hope some of you have seen Unity before. If not, doesn't matter so much because we're rather looking into the code. First of all, in Unity, I have my main camera. The main camera here is basically the HoloLens, the user's head, right? If they're moving, this is the camera in our 3D scenery. And what I have as a child of the camera is a little log text here. This is the little text you have seen. I also have a light in here, and most importantly, I have this ASA manager. And this ASA manager is a game object where I attached a script to it. And this script here, this ASA handler script, that's a custom script that handles all, well, the ASA stuff. And of course, it has a reference to the log text, so it can update the log text. And here you can see the prefab here. That's basically in Unity, it's a template. It's a template of an object that you can instantiate during runtime, right? So I have this little prefab here, like this is a meatball. It's a long story. I gave a talk many, many years ago at a conference in Sweden. So I made this little meatball. I was shooting with a HoloLens into the audience. We're not going to do that today, but I keep on using this asset. Anyway, so we have our little prefab, which we want to instantiate when the user created an anchor. And but all the functionality is basically here in the C# script. So let's open that in Visual Studio. So first of all, again, if you have not used Unity before, one specific thing is if you want to attach code in Unity, you have to derive it from mono behavior. And then you can attach it in the UI basically to any game object. You can attach this kind of script to it, right? And then Unity will call this start method. once it initializes this game object it's attached to. And what we do here is we initialize this gesture recognizer, which is basically recognizing for gestures the user is performing. And in this case, I'm just interested in the tap gesture from the user, right? So when the user taps like this, I'm just interested in that. And then I'm basically attaching this little event handler in here. And so when the user taps, this event handler will be fired. Then I say, okay, start looking for these kind of gestures, and then I initialize the session here. So what it does is basically, first of all, it creates an instance of the Cloud Spatial Anchor session. We attach that or save that in a field here. And then we gotta define our configuration. So we gotta assign the account ID and the account ID and the account key from our Azure Spatial Anchor service. So of course we're using Azure. We gotta set up a service here. So let's switch quickly to my Azure portal here. So how would you do that? It's really simple actually. You just do create resource, and you can find it on the Mixed Reality. It's right here. Or you can also just type it, right? And well, you click create, give it a name, like this, doesn't matter, like this. And of course, you want to choose something that is closest to you, so probably West Europe. And then, well, you hit create. It will create our ASA service and deploy it on Azure in the data center there. Done. Okay, so two things you would need. You need this account ID here, right? So you saw that in the code. So you plugged it in here, basically. It's just a string. And access key, primary key here, that's the one you also need to copy. That's your account key. There are also, of course, other ways to authenticate, right? You can do OAuth and other authentication methods, which are probably better suited for production environment. But to keep it simple, I've chosen this way. Let me just quickly delete this real quick because I've shown you the account IDs. So I don't want to forget to delete it later on. So I'm just going to delete that right now because, again, I've showed you all the IDs there. So okay, I'm just deleting that real quick. Of course, you would not delete it, right? So forget about this. I'm just doing that because I've exposed the account IDs here. So you have your Azure service set up, you plugged in all the keys and IDs and whatnot. Now we're attaching a bunch of event handlers here, session updated, anchor located, and arrow, and then we basically start our session. So everything initialized, and now, like I said, once the user does this tap, this interaction, we go into this one, into this event handler. And first of all, we're doing a little bit of check, you know, that they don't tap like all the time. And then I'm checking a string here, a current cloud anchor ID. And if that is null or empty, I go into the create and save anchor, right? And so what it does here is it does array cast. And what array cast is, it's basically you take your camera position and your camera forward vector. So basically, when you're wearing the HoloLens, like camera position is like somewhere here, right? And the forward vector, well, is the vector in forward like this, right? So it's basically, it's telling you where is the user looking. And so what we're doing is we're shooting out array into the scenery. And I haven't showed it to you, but there is, of course, a spatial map in the code here, in the Unity, the spatial mapping collider here. It's being used. And so that allows me to basically use the spatial map of the HoloLens for collisions. So basically, when the ray hits the spatial map, it will load that it will give us back where was the raycast hit point. So you have this raycast hit point, right? Once you do the raycast, and this is basically the point on the real world where the user was looking at, and this is where we want to create the anchor. And so I use that point. It's a vector free, so a 3D point, a 3D location, and instantiate my prefab, right? The little meatball visual. And then what I do is I attach a local anchor. So this is interesting because we're using the world anchor from the HoloLens, right? If you would do a cross-platform application, you would probably do a pre-compiler directive here to, rather choose an anchor from Android or an AR anchor on iOS, or you could also use Unity AR Foundation, which takes care of the various anchors. But to keep it simple, for the HoloLens, we're creating a world anchor, like a local anchor just on a device. And then we're attaching it to a cloud spatial anchor. So we initialize a new one, and then we assign our local anchor, a pointer basically, to our local anchor to the cloud anchor, right? So now we have our cloud anchor. And the next step is we need to upload it to the Azure Spatial Anchor service, right? And I do this here in a little background thread. So, you might write your background thread a little bit differently. That's just a quick way how I do it sometimes. And what I do here is I check this field if I have enough data, right? So if it's more than 100% basically, or equals 100%. And then I jump out of this. So where does this value come from, and what is that actually? Well, I mentioned it to you. There's this kind of event handler, right? Session updated. And this session updated in the args, it provides me a value recommended for create progress. And what this value contains is basically, has the user looked around enough, right? So, because I need these feature points, I need enough information to later relocalize it again. So the user needs to be able to look around, and you need enough information. And this will basically be updated in a background thread. And so I get this kind of value, then I check it here in my little while loop here, and wait until the user has enough information. As you can see, I also print out little text, right? Look around to capture enough anchor data, basically. So once we have enough data, we can create the anchor. And so we can upload that anchor asynchronously with the create anchor async method. And once it's done, our identifier is hopefully not null. And that means the anchor was successfully created. And basically, we save that ID that we got returned from the service, right, in this little field here. So now I have this ID locally saved. And once the user taps again, it will do the if again, right? And so this is not null this time, so it will go into this branch. So we know, okay, we have an anchor ID, I want to localize it. And what it does is, first of all, it cleans up everything. So we're cleaning up all the game objects that were being instantiated. We stop the session, we dispose it, we null it, and then we initialize a new session. So I want to make sure like everything is clean, right? All is gone. We don't have any information from the previous session. Only we save the ID in a string. And then I create an anchor locate criteria. And this criteria is being passed into a watcher, right? And this watcher will then run in the background and basically look for a match to that criteria. And what I use here is the identifiers, right? So like I said, I have the ID. You could basically have an array of IDs that you can pass in, so you can actually search for multiple anchors at a time. Another way is, like I mentioned, identifiers is one way. The other way would be near anchor. So this is a near anchor criteria, right? And here you would, for example, pass in a source anchor. So if you have like a wayfinding, you would do it like this, right? So you would pass in the source anchor until you get always the next one. This is for wayfinding scenario. And the third method, which is really useful for production scenarios, is this kind of near device. So I can do this near device criteria, and then you can define distance in meters. And so this would give you all anchors that are basically, you could, whatever it is, right? 50 meters, 100 meters around you. There's a little bit more configuration you would have to perform, because it would use like Bluetooth, Wi-Fi, and also GPS and all of that data. So you need to, of course, on these mobile platforms, right? You need to have the right capabilities enabled. But basically very useful for production scenarios. But in our case, let's go back to that. We're using just ID, create the watcher, like I said. This will run in the background. And at one point, it will fire this event handler. It found the anchor. And what we do here is, we first of all dispatch, because this is being triggered on a background thread. And we want to create UI elements. We want to create a game object, right, with this little meatball thingy again. And so we need to go into the UI thread. So there's a little bit of dispatching here involved. Next step, we instantiate a prefab again, attach a local anchor just as a dummy, because now we're actually taking the arguments that is provided here that gives us the anchor, that gives us the cloud anchor, right? So this is our cloud anchor that we got back from the servers. This is the one it found. And it, of course, also has the local anchor property. So basically, now we do it the other way around, right? We take the anchor data from our cloud anchor and attach it to our local anchor placeholder, if you will. And what it would do now it would move that game object that I instantiated to the exact location with the correct orientation as well as it was saved. Okay, that's pretty much it. Then we delete it. Well, just because I do some housekeeping here. Then, null it again and say tap 0 or false. So basically we can do this loop endlessly, right? Tap, create, and so on. That's it. That's pretty much the minimal things you need to do in order to use Azure Spatial Anchors. And like I said, there are a bunch more samples which are better suited for production with the Mixed Reality Toolkit, for example, and so on. But this, I think, is a good way to understand how easy actually the API is to use. Okay, so we still have 9 minutes here, and we have some time for Q&A. But before we do that, you might want to get ready with your questions already, if you have one. Here's a bunch of samples or links, actually. So first of all, there's my name. Feel free to connect on LinkedIn with my name. Also, Twitter handle, email. So if you don't want to ask a question now, you can also reach out via another channel. Then a bunch of links here, demo code. The minimal demo I've just walked you through, you can find it there. Then I have another one with the MRTK. This is it's called the Mixed Reality Toolkit. It's basically a UI framework. It's actually more than a UI framework, but it's a framework you would use in order to build production applications for mixed reality. And so there's also another way you would use ASA with it. Azure Remote Rendering, you can find this nice showcase app there, which does all of that. Bunch of documentation to ASA, Azure Remote Rendering, object anchors, and MRTK. And the last one is also a very useful tool if you're doing mixed reality development. It's called MR Feature Tool, which allows you to load these packages nicely. Okay, so 8 minutes. I guess that's it. Do we have any questions? No questions. Everyone is done with its. Oh, we have a question. Yeah, go ahead.
Right. The term metaverse was used quite a bit throughout your presentation, and there's another company that's trying to kind of take the word metaverse as their own.
Yeah.
So, what's the story there?
Yeah.
You use the word Microsoft Mesh as the term for this implementation?
Yeah, no, it's a great question, actually. I'm just working on a deck, actually, around this whole metaverse stuff, because it's like at the moment, this metaverse term is everything and nothing, right? It's like a qubit, with quantum computing. It's like multiple things at the same time, kind of. Like everyone has a different understanding of it. And so Facebook rebranded to Meta. What they're building is this kind of what I have call a virtual metaverse. So what they basically are building is the successor to their social media platform. And so instead of going to a website, where you can interact with your friends, you go in this virtual world. They are building a thing called Horizon Worlds, where you're being represented as an avatar in 3D world. Then you can also, hang out with your friends. And well, I give you my honest opinion about it. They just want to draw in more people, that they stay longer in their experiences so they can sell more advertisement to it and manipulate them better and do all of that. It's a very, if you look at the metaverse and from the sci-fi where it comes from, there's a bunch of books, like the Snow Crash one, where the metaverse term was established, but also Ready Player One, which is pretty famous. It also has this oasis, this kind of metaverse kind of thing, right? Where there's in the future, we have this super crazy world, like everything is broken, like climate, everything, it looks like Mad Max or whatever, right? This kind of crazy world. And so folks go into this oasis virtual world to escape this dystopian reality, right? And I think Facebook is building something very much close to that. And that's not something I think is what we are talking about when we talk about an enterprise metaverse, right? Because there's, of course, a play outside of this, first of all, this full virtual world. I call that, and others, you also see it from Niantic, and so they call it a real-world metaverse. So basically, it's closer to what I've shown you with the AR cloud stuff. So you have the real world, right? You have all these devices that can sense and understand the real world, and you have this real-world metaverse layer, a digital content layer on top of the real world. Right? And then you can have meaningful experiences because we can bring in computing, we can bring in the real world into computing with these kind of experiences. And if you look at what Microsoft is doing with Mesh, Mesh is a platform for building metaverse apps, basically. And Mesh for Teams, for example, is a gateway into this kind of enterprise metaverse, because you have 250 million Teams users in the world. And it's an easy path for them to go into this kind of 3D immersive spaces. So you can create these 3D rooms basically there. You can also be represented as an avatar and go into these immersive spaces and, well, have more interactions and more immersive conversations and collaboration with your colleagues. But you can also just, in a Teams call, you can also, instead of turning on your video, you can be represented as an avatar. They do like body tracking. So the lips of the avatar will move correctly. Your hands will move correctly. That might also be an easy way. And so people might get used to that and see maybe benefit to use that in a corporate environment. And that is rather something, that's why I call this enterprise metaverse and try to differentiate a little bit from this full virtual metaverse. Because if you look at what Facebook is building, actually, it's already here. If you look at Fortnite, Roblox, and all these social online gaming worlds, right? These are huge. If you have kids in that age, you probably know, right? You got to restrict the time for Roblox and Fortnite and all of that, because like it's so addictive. But it's also very social, right? You have a lot of friends in there, so it's not just gaming. And so this is actually the first incarnations of this kind of virtual metaverse is already here with these kind of games. And the next level is of course this full virtual metaverse. So it's hard to unpack. I'm still working on this kind of deck to unpack that a little bit, also visually. But maybe next time we can talk a little bit more in detail about it. Another question there.
I have a question about spatial mapping. You showed that for a little bit in HoloLens, that mesh you see of the real environment around you. For my use case, it's quite the opposite what I would need. I don't want to render 3D objects over real world, and I use different mixed reality headset. It's Reverb. And I would like to render the.
Can you speak a little bit louder? It's really hard to understand.
Yeah, sorry.
Like this.
Could I use spatial mapping with different mixed reality headset than HoloLens in the future?
Yeah. So ASA, Azure Spatial Anchors, is available for iOS, Android, and HoloLens. And there are some experiments basically, with a little bit of hacking to get it into your Oculus Quest, for example, right? Because it also has this kind of cameras, right? Tracking cameras. Like, of course, it's a VR headset, but it also that's why I say it's also a spatial computing device, because it knows where it is in the room. It has information about its environment. And with the Oculus Quest, a fantastic device, by the way, you get the see-through mode, not see-through, sorry, pass-through. They use the cameras and have very short latency. So although you're in a VR headset, you can enter this kind of AR mode, kind of, because it's just, you don't see it with your own eyes, but you see the cameras from the device in a black and white frame. But still, it's a good way, and it's a 400 or 500 euros device to use that. But at the moment, there's no ASA for Quest, as far as I know. But I think there's some work in that space. We have another one.
Yeah, here.
Yeah.
I wanted to ask about spatial anchors. Like, is it a combination of GPS and visual
mapping?
Visual mapping, because will it work, for example, if you move the furniture? Or
I think I understand it how roughly. So Azure Spatial Anchors is in its essence, it's using computer vision. So it's just using camera data, but it's extracting only the relevant information, the feature points from it. And that's the way how it recognizes it. So basically, you create an anchor, you scan around, capture all the feature points, you save that into the cloud. Then if you want to localize it later, you ask the cloud, or you ask the ASA service, okay, I want to find this in that anchor, and then you scan around, and so it creates another point, or it captures this kind of feature points from your current and compares it basically to the anchor. And if there's enough overlap, it will say, oh, I found the anchor, that's the one you searched for. So it's just visually based. But you can combine it with GPS, Bluetooth, and Wi-Fi fingerprinting, another way of localizing, basically. to give this kind of, it's called coarse relocalization. So this could be your first step. Use GPS to say, okay, I'm in the city center of Prague, right? So this is my location, kind of. And then you say, okay, give me all anchor data 100 meters around me. And then you, of course, do still the scanning, but you don't have to provide an ID. So that's the real benefit of it. Does it answer the question?
Yes, thank you.
Thank you. All right, we're at the end of the session here. Just want to say thank you for the attention here. I know that was the last session of today of a long day, and for a lot of us, the first in-person conferences again since a while, so I know that is a really, really tough time, so really appreciate that you guys stayed here. I think an exciting time to be alive. We see really this kind of science fiction technology we imagined coming to reality, right? With devices like spatial computing devices, plus this kind of AR cloud or real-world metaverse where we can have these meaningful experiences and collaborate with each other with these kind of devices. Exciting time to be alive, and thanks for staying here, and enjoy your people.